Hi, welcome back to the channel. In today's lesson, we'll use this example to see chain rule method of differentiation. At the end of this example, I believe it will help us to apply different methods of differentiation. That said, let's get into class. Now, if you look at the example says we have y to be equals to the square root of 1 plus t squared, and we have t to be equals to x plus 1 over 2x plus 1, when x is equals to 1. Now, the first thing I want to do is when x is equals to 1, what is the value of t? Now, when x is equals to 1, t obviously will be the same thing as 1 plus 1 over 2 into 1 plus 1. I simply substituted for x with 1. That will be the same thing as 2 over 2 plus 1, which is equals to 2 over 3. Now, if t is equals to 2 plus 3, what we're actually looking for is dy dx. Now, look at this carefully. Here we have y in terms of t. Here we have t in terms of x. Now, so from the first equation, from y here, what we can derive dy dt. And from this other part of the equation, we can also derive dt dx. So when we look at it this way, when dy dt multiplies dt dx, obviously dt will cancel dt here, then I'll be left with dy dx. So what am I going to look for? I am going to look for my dy dt, and I'm also going to look for the value of my dt dx. Already we have the value of x, let's keep that, and also we have the value of what? Of t. So let's get started looking for dy dx, and let's get started looking for dy dt and dt dx. Now my y is equals to the square root of 1 plus t squared. The first thing I want to do here is let my u equals 1 plus t squared, so that the u dt here will be the same thing as, if you differentiate 1, it becomes 0 because it's a constant. But when I differentiate t, when I differentiate t squared, it becomes 2t. Remember the formula we have applied is y. If y is equals to ax raised to power n, my dy dx will be the same thing as anx raised to power n minus 1. Now let's get back to our function. This is just by the way. Now we have said that u is equals to 1 plus t squared. So that my y now is the same thing as u raised to power half. So that the y now, the u from here, will be the same thing as half u raised to power half minus 1, which is equals to half u raised to power minus half. We already have the u dt, and we have the y du. So from here, I can always derive my dy dt. So that the y dt is du dt times dy du. So that here I can say that my dy dt will be the same thing as dy du is half u raised to power minus half. Let's write that down first. Half u raised to power minus half times, then my du dt is something as 2t times 2t. So if you look at this carefully, 2 here can definitely cancel 2 here. This will be the same thing as u raised to power minus half times t. Let's interpret this properly. Now this is something as writing t over the square root of u. And remember that we had assumed u to be the same thing as 1 plus t squared. So I can replace that, so that this is something as t over the square root of 1 plus t squared. Now, if the y dt is t over the square root of 1 plus t squared, remember we have gotten the value of t. From here, t is 2 over 3. That means I should be able to substitute 2 over 3 in this position. So that this is the same thing as 2 over 3 over the square root of 1 plus t, that's 2 over 3 again, all squared. So that my dy dt is the same thing as 2 over 3 all over square root of, if you process this, 1 plus 2 over 3, that becomes 1 plus 4 over 9, which is the same thing as 2 over 3 over square root of 13 over 9. This is the same thing as 2 over 3 all over square root of 13 over 3. Now we can rearrange this so that my dy dt will be the same thing as 2 over 3 times 3 over square root of 13. 3 here is 1, 3 here is 1. So that this is the same thing as 2 over square root of 13. Now this is just dy dt. Now what is the value of my dt dx? Now what's the value of this? Now let's get into work. Now again, you know that t is equal to x plus 1 over 2x. T is equal to x plus 1 over 2x plus 1. Now, if you look at this carefully, you see that this is division. So we're going to apply my division rule so that I'll say that if u is equal to x plus 1, my du dx will be the same thing as 1. If v is equal to 2x plus 1, my dv dx will be the same thing as 2. Now, from my division rule, let's just take my division rule says if I have u in terms of as a function of x, I have v as a function of x, my dy dx will be the same thing as v du dx minus u dv dx over v squared. So in place of each of these, we'll start substituting. I've gotten v, I've gotten the u dx, I've gotten v, I've gotten u rather, the u dx, I've gotten v and the v dx. So let's substitute. My dt dx will be the same thing as v du dx. That's my v is 2x plus 1 and my du dx is 1. That's 2x plus 1 and du dx is 1 minus u dv dx. My u is x plus 1 and dv dx here is what? Is 2 minus 2 into x plus 1 all over v squared. Remember that my v, let's say my v once again, 2x plus 1. That's 2x plus 1 all v squared, all squared. So if we expand this is the same thing as 2x plus 1 minus 2x minus 2. I have minus 2 here multiplying 1, then into 2x plus 1 all squared. Now so that dt dx will be the same thing as 2x minus 2x gives way for each other, becomes 0. Then I have plus 1 minus 2, that's minus 1 over 2x plus 1 all squared. Now, dt dx at x is equals to, let's find the value of x. Let's just remind ourselves of the value of x. X is equals to 1. So if x is equals to 1, then at x is equals to 1, the whole of this becomes minus 1 over 2 into 1, that's 2, plus 1 all squared. That's equals to minus 1 all over 2 plus 1 is 3, 3 times 3, that's 9. Remember we said that our dy dx would definitely come from dy dt dot dt dx. Now what's dy dt? Let's go back to it. Dy dt is the same thing as 2 over 13 over root 13. So that will be equals to 2 over root 13 times minus 1 over 9. This is the same thing as minus 2 over 9 root 13. So this is the value of dy dx. Thank you once again for staying with us. With this, I hope you further understand how to apply chain rule or the composite function in differentiation. Thank you for staying with us and see you in our next class.